Have you ever looked up at the night sky and wondered what those twinkling stars are made of? Or even better, have you ever wondered where you came from? The answer to both questions is the same, and it's one of the most incredible stories in the universe: stellar nucleosynthesis. It sounds complicated, but it's the cosmic recipe that created almost everything you see around you. Yes, you, me, this planet. We are all made of stardust. And today we are going on a journey deep into the heart of stars to find out how it all happens. So let's start at the very beginning. The universe began with the Big Bang, which created the simplest and lightest elements. Mostly hydrogen, a good amount of helium, and tiny traces of lithium. For millions of years, that was pretty much it. The universe was a vast, dark expanse filled with giant clouds of these simple gases. But gravity, the universe's master sculptor, had other plans. It began pulling these gas clouds together, packing them tighter and tighter. As the pressure and temperature in the core of these collapsing clouds skyrocketed, something amazing happened. A star was born. The core of a young star is an unimaginably extreme environment. We're talking temperatures of millions of degrees Celsius. At these temperatures, the hydrogen atoms are stripped of their electrons, creating a sea of protons and electrons called a plasma. The pressure is so intense that it overcomes the natural repulsion between positively charged protons, forcing them to fuse together. This process is called nuclear fusion. In the most common process, known as the proton-proton chain, 4 hydrogen nuclei, which are just single protons, fuse together through a series of steps to create one helium nucleus. Now, here's the magic. If you were to weigh the 4 hydrogen protons and then weigh the 1 helium nucleus they create, you'd find that the helium nucleus is slightly less massive. So, where did that missing mass go? It was converted directly into a tremendous amount of energy, according to Einstein's famous equation, E=mc2. This energy is what makes stars shine. It pushes outward from the core, creating a perfect balance against the inward pull of gravity. This balance, called hydrostatic equilibrium, allows a star like our Sun to burn steadily for billions of years, constantly turning hydrogen into helium. For most of a star's life, this is its main job, fusing hydrogen into helium. But what happens when the hydrogen in the core starts to run out? This is where the story gets even more interesting. Without the outward push from hydrogen fusion, gravity once again takes over and begins to crush the core. This compression heats the core to even higher temperatures. We're talking over 100 million degrees Celsius. At this point, it becomes hot enough to start fusing helium. Through a process called the triple alpha process, 3 helium nuclei fuse together to form a carbon nucleus. This is a monumental step. Carbon is the fundamental building block of life as we know it. From this point on, if the star is massive enough, a new cycle begins. The core fuses helium into carbon, and once the helium runs out, the core contracts and heats up again, starting the next stage of fusion. In stars more massive than our Sun, this process continues, creating heavier and heavier elements in concentric shells, like a cosmic onion. The core fuses carbon into elements like oxygen, neon, and magnesium. As each fuel source is exhausted, the core contracts and heats, igniting the fusion of the next heaviest element. This continues, forging neon into oxygen, oxygen into silicon, and finally, silicon into iron. Each of these fusion stages releases energy, which continues to support the star against gravity. But it all comes to a dramatic halt at iron. Why iron? Because fusing iron doesn't release energy, it actually consumes it. Iron has the most stable nucleus of all the elements. So, when the core of a massive star becomes a solid ball of iron, it has reached a dead end. The star's internal furnace shuts down. With no more energy pushing outwards, gravity wins the final battle in the most spectacular way imaginable. In less than a second, the iron core collapses catastrophically. The outer layers of the star, which were still happily fusing lighter elements, suddenly lose their support and come crashing down towards the core at incredible speeds. They slam into the now super dense core and rebound in a titanic explosion known as a Type II supernova. This explosion is one of the most energetic events in the universe. For a brief period, a single supernova can outshine an entire galaxy. And it's in this fiery chaos that the rest of the elements are born. The incredible energy and flood of neutrons produced in the explosion allow for the rapid capture of protons and neutrons by existing nuclei. This is how all the elements heavier than iron are created: gold, silver, platinum, lead, uranium, all the precious and heavy materials we know on Earth. The supernova then blasts all these newly forged elements: the hydrogen, helium, carbon, oxygen, iron, gold, and everything in between, far out into space. These enriched clouds of gas and dust are the raw materials for the next generation. Over billions of years, gravity pulls this stardust together to form new stars, new planets, and on at least one of those planets, new life. Think about that. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now, every single one of those atoms was forged in the heart of a star that lived and died long before our sun was even born. We are literally the children of the stars. The universe isn't just something out there to look at, it's inside of us. It's an unbroken chain of cosmic creation, from the Big Bang to the stars, and from the stars to us. So, the next time you gaze at the night sky, remember that you're not just looking at distant points of light. You're looking at the giant cosmic factories that built our world and built us. It's a humbling and awe-inspiring connection that ties us to the grand tapestry of the cosmos. Thank you so much for joining me on this journey through the stars. If you found this as fascinating as I do, please hit that like button and subscribe for more adventures into the wonders of our universe. And don't forget to share your thoughts in the comments below. See you next time.